these things are super casual. I had Jeffrey Huntley on here about 3 weeks ago, who was the creator of the Ralph Loop,
Cool.
and I really like the vibe.
Oh, you know what? I
Yeah.
think I think I got that video recommended to me on YouTube
Oh,
because
cool.
I was just thinking like your face is very familiar. I think that's where I think I saw.
Okay.
Yeah, I think I saw the video.
That's
Yeah.
cool. So I've been obsessed with context for a long time now, and to the degree where I went and wrote a book about it. So we'll just kick off into this conversation so that I can pick apart things that are worth sharing to people. But for those that don't know me, I'm Ian Pilon, and I wrote a book called Cultivating Clarity, but it's about contextual intelligence from a customer's framing. How do we understand upstream what customers are trying to do? And then I went on a journey to talk to over 9 people and really parse what it means to understand the context of your customers. Published a book about this, shared it at my last event alongside Sam's book, and I'm going to do a screen share. I actually don't know if this is going to work because this studio software has been kind of buggy, but I'm going to try and see what it does here. Um, oh, it's working now. Okay.
It's
So, yeah, I just ran an event, uh, or Mastra was a sponsor, and they sent me a bunch of books, Sam's books, and I put them out and alongside my book, and they're all
oh, that's
gone.
awesome.
Yeah, they're all gone.
Amazing.
Yeah, and then this is how I came to know you, Tyler. I also seen your post on X and about observational memory. So in my book, I talked to Michael Levin in particular goes quite deep on the biological side of what memory is in individual cells because he does a lot of pioneering research on regrowth of limbs, and he does the most advanced stuff related to memory. So had a great conversation with him on the biological side of agents and how memory works, and it's just a fascinating rabbit hole. But to sort of
Definitely.
ground that to ground that here with Tyler, we're going to talk about sort of like the engineering layer of this abstraction so that we can bring it down to earth and then go, okay, well, with the explosion of agents in software, how does memory work? So, Tyler, maybe help the audience understand who don't already know you. What are you doing with Mastra? Who are you? And then we can kick into some conversation.
Sure. Yeah. So I'm a founding engineer at Mastra. Um, I think this may be like a year and a half ago that I joined. So like the company's pretty new. Like I joined fairly early. And I've always been, since the start, actually been working on memory. Oops. So I think like my first week, I created our first like memory implementation, and then just been like maintaining that and like building all kinds of other things as well. And then, you know, just came up with observational memory in the last, I think it was like 4 or 5 months. And it was just, the result of all this prior work, and understanding of like working with users and like building agents myself and all of that. So
Very cool, very cool. So let's go back there because I didn't know you were doing it since you started at Mastra. But let's go back that far then. So why was it that you were sort of triggered into the memory side of the architecture? What led to that um, path
I
for you?
I think it's just that it's feels like it's always been kind of like an unsolved problem, and it's a very important part of the whole, like a very important layer of the system, right? Like if an agent can't remember, it's not going to be very useful at all. And that like, so before I joined Master, I was working on like my own coding agents before that, and that's sort of what fed into actually joining and working on memory. But I think a lot of people who use coding agents specifically, you'll see like the memory works really, really well until the context window fills up, and then you'll hit compaction, and then it does not work so well from that point, right? So it's like, oh, like, well, what is the problem here? Like, why does this reset happen, right? So that always interested me. Yeah.
Okay, well, and then that ties into Jeffrey Huntley's work where he discovered this same thing, calls it well, I actually don't know if he coined the term context rot, but you talk about it in the Mastra. blog post about it. But you started to see this very early, and so did I when I was tinkering around with AIs and I was trying to write my book. I was using it as a ghostwriter,
Mm.
and I realized they have this boundary space, this limitation. And I felt like if the tighter the leash that I kept it on and refreshed my sessions, I would have almost like I don't know how to describe it, but just it felt like the conversation would stay on the rails a little bit longer. Where was it when you discovered that, because this all happened so fast, that you realized the limitations of LLMs, and or like were you interested in memory before even LLMs, or was this because of playing with the new technology?
Um, I mean, I wouldn't say it's like an area of interest before. I mean, I guess I've always been interested in the mind generally, right? Like
Cool,
I was
cool.
into meditation a lot and like lucid dreaming and things like that.
Okay,
So I'm sure
okay.
that kind of feeds into it, but it wasn't something that I was interested in specifically before LLMs. It was really like experiencing this problem and be like, okay, there's a problem here that needs to be solved. Like what you were just describing of, you're using it as a ghostwriter and you sort of needed to manage the memory yourself by just understanding, oh, it's going to fall apart in these ways. So like you're almost like patching it with your own human memory, right?
Yeah.
You're like, I remember how this works. I need to kind of guide it into remembering the right thing, which is totally backwards for like a piece of software, right? Like it should just work. So
Yeah, now that you said that, yeah, I would get so far, and then I would save a lot of my work as files. So those were my contacts. I would get so far, I'd have to stop the session with the LLM. And I was trying to stitch together, well, how do I go from this discovery call I did, because I did 9 discovery calls, and how do I stitch that into an arc that goes from one chapter to a next? And I remember now that you mentioned that yeah, I had to, um, I would feel like I'd be in a rhythm with the LLM for a while, and then I'd have to, like, drop it and come back the next day, and then, yeah, start all over again. It had no recollection of whatever I did last session, because this was before, I think, ChatGPT started even adding, any type of memory into their system. It was really early, so I have Miro boards, and that's what I'm looking at here, by the way. I have a Miro board that I follow,
oh, nice.
and I started using that as my external memory to keep track of where I was going with the LLM, and sort of taking screen grabs. And so for other people that are sort of catching up, I will do sort of like another quick screen share here to show, I guess one of the tweets that or X posts that I think, which one was it that I found? I don't know if it was the one on February 9th, but which one popped off, that you felt went viral?
The
Was it this one? I
yes, it
can't
was
remember
it
what
was
it
this one. Yeah.
Okay.
There's
So
a
this
lot of interest in this new system.
Yeah, and this is where I reached out to Sam, and I'm like, "Hey, like, let's talk about this. You guys are sponsoring my event." And anyways, he says, "You gotta talk to Tyler." So here we are. But walk us back through this. So now you've been at Mastra, and I think you said, was that a couple years before that led to this? And then
I think about a year. Um, so like I said, I sort of built a very simple memory system in the beginning. It was like there were a couple aspects to it. So one was message history, just the last n messages, right?
okay.
And there was semantic recall, so that's RAG, right? So doing a vector query, pulling in related messages into the chat on every turn. And then we had another feature called working memory, where the agent would sort of update a context store via tool calls. Now, all of these things together did actually work pretty well. So we initially did like a long mem eval benchmark run. So it's a pretty good memory benchmark. I think we got like 80%, which is it's actually a pretty high score um, back then. But there were a lot of problems still with the system, like RAG specifically. When you're dynamically pulling in context like that, you're invalidating the prompt cache in every request, right? And that's going to make it way more expensive to use. And then also, what happens when you get too much signal in like your RAG database? How is it going to know like what to actually pull in? And then you need to add like free ranking systems, and it starts getting very complex, right? So I kind of had all this in my mind as I was working on like my own coding agent, because that's always how I've liked to kind of like uh, do research into AI and like actually like, build features and test things out is like because I'm coding all day, right? So if I can make my own tool that is using these things, that's the easiest way for me to sort of dog food and try it out.
Yeah.
But as I was doing that, I kind of I had this problem in mind, right? And really, for coding, out of the systems that we had initially, the only one that really worked very well was the message history, right? Just the last n messages, and that's a pretty poor memory system, right? Because once you get to the context window, just fills up, and then now you need to compact, right? Like Cloud Code does or Codex. Um, and when that happens, you lose a lot of info. Like often the agent just seems to totally forget what was happening, or like it has a general idea, but like it forgets everything that you kind of like the problems you went through together, or like the details of things and all that, right?
Yeah. Yeah.
So, um, like I don't know, it was maybe like 2 or 3 weeks of just kind of like thinking about this, and I just sat down and I was like, hey, what if I just try to make it work more like how my mind works, right? Like I definitely do not have an exact transcript of every single exchange. Like for example, right now, like on this podcast when we're talking, like I don't remember every single word that you said, right?
No, exactly.
And I don't need to, right?
You don't need
Because
to.
sort of that's not how human memory works.
That's right.
So I was just thinking, like, why do coding agents or just agents in general, like, why do they need to work that way, right? Like the context window in every request, you're sending back like 50 exchanges back and forth. And that just seems such a strange thing if it doesn't work that way outside of LLMs, right? Um, so I guess the idea was to sort of flip the script on that a little bit of like, okay, maybe the message window is actually sort of like human working memory, right? Because I do remember like the things you and I have just said over the last like 30 seconds or a minute, right? But
Yeah.
maybe not like
Yeah.
5 minutes ago.
That's right. That's right.
So like we do have a bit of that, right? But not like hundreds of exchanges or whatever.
Yeah. 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 Yeah.
So it's like,
It'd be
okay,
too
so,
expensive, right? Like it
oh
would take too
yeah,
much energy, right? Yeah. Keep
you'd
going.
be sitting there thinking for like 30 seconds before you said anything.
Yeah. 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 Yeah.
So from there, I was like, okay, so that obviously can't be like the whole component of the system. So like beyond that, like what happens for me? So when I'm coding, I realize, oh yeah, I do sort of have like this subconscious observation of what's happening, right? Like, like you know,
Interesting. Yeah.
I edited this file and that file, and it was for these reasons, and then oh, I found out that when I did that, I broke this other thing, or like now this test started failing, right? So I do remember those things, right? Like maybe not the
Interesting.
exact details, but like
Yeah.
this log of events,
Interesting.
right?
Yeah.
So
Yeah. Yeah. Yeah.
um
That's crazy, right? Because it's like the observer. And as you mentioned, you're into meditation. So once people get into meditation, then it gets down to a rabbit hole, like who's watching the watcher here, and
yeah.
you're observing your thoughts.
Exactly.
And
Yeah.
but I also liked how you framed it around the subconscious. It wasn't like there's not
Mm,
effort there, but it's
yeah.
this other stream that is sort of like, I don't know, like a fuzzy sort of holding of that, maybe just in case you want to go back to there. And then sorry, did you have anything else you wanted to add to that, Tyler, before I steer
I
it any?
I mean there's more, but like
Yeah, please go ahead.
we
Go
can
ahead.
just kind of like I mean naturally go through it.
Well, I was going to just say that you're using it heavily in the context of a coding agent, which is amazing. And then I just want to sort of like unpack that for people that may not be you building their own coding agent about why this might matter. And I think it's relevant now with the open claw hype
mm,
cycle that there are people, including myself, like I'm not going to build my own coding agent. I'm interested in like business. So, but
mhm.
more and more people that don't know how to code are downloading claw bots, and all of a sudden, like I'm even doing this. I have um, my open claw inside of WhatsApp,
Nice.
and I'm telling it what to do and to go do the coding, like just, hey, can you go do that for me?
Right. It could just kind
Like
of like
that's
work on itself, right? You
yeah,
can just
yeah, yeah.
add
Well,
things.
yeah, and
Yeah.
I actually took your architecture because it was a tweet, and I was like, oh wow, somebody's doing some really complex memory architecture there. So, but now, and my agent called himself Ren. He has his own name. He came up with it. So I'm like,
Nice.
cool, whatever. But to me, I'm like, I don't know whether underneath the hood, if this thing is running TypeScript or not, or what language
Mm,
it's using to be a bot or an
right.
agent. But I do know that I'm like, well, even if it doesn't speak the coding language that, let's say TypeScript or something, I'm just like, hey, this architecture sounds pretty interesting. Can you tell me if you're doing anything like this? Is basically what I said to it
Hmm.
as a text message. And then it read your model, and it's kind of like, well, actually, no, I don't have anything like that, but that's cool. Do you want me to implement it? And I'm going to do another screen share here.
That's crazy.
Yeah, and I gave it I gave it the tweet, and I'm like, hey, what can you do like this? And it goes, well, blah, 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 blah. And it spits out this logic that it can come up with something along
Mm,
these lines, this three dot model, but maybe help other people unpack this that are maybe not thinking about building coding agents,
yeah.
but want to understand why it's important. Maybe if they've got a claw or an agent in the future that they start to reason with, it help them understand maybe why that's important.
Yeah. So I think so. One of the reasons that I like testing these things through coding agents is that they use tons of context, right? Like so many tool calls, like reading all these files, running commands, doing web searches. So you sort of like you actually kind of speed run the need for a good memory system when you're coding.
Okay.
Because like with a regular chat, like let's say it could take days to get to the full context window size for some people, right?
Okay.
Not for
Okay.
everyone. With the coding agent, you might hit that in like 5 minutes or like 10 minutes. You know what I
Oh,
mean?
yeah, 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 yeah.
So the interesting thing, I guess, is that this is like it's a general problem, right? For coding agents, they just hit it much more quickly.
Yeah, and why is that? What is it that that is so much context that they hit the windows faster than
I
other
think
ways?
it's really about just reading tons and tons of files and like editing
Okay.
files. Like files just use tons of context space to read, or like running commands, like running tests, doing web searches and things like that. Um, so the same problems, you'll have them with any agent. It doesn't have to be a coding agent, right? And I think that's even like
Yeah.
what you're talking about, seeing like using it as a ghostwriter, right? Actually,
Yeah,
that
yeah,
that might use a lot of context too. I would think, right?
yeah, yeah,
Reading lots and lots of text.
yeah.
Um,
Well, that's exactly it. I ran into a wall where I'm like, okay, take this interview. Well, most of them were an hour long, and I'm like, I need to find the continuity between the story around context from this person's perspective, and then the next person where I want to go to the next chapter. How do I? So I'm trying to give it two of these chapters, and then going like, help me figure out if there is an arc to get into the next chapter. So you're right,
mm,
that's a lot of context. But I
yeah.
think in the coding scenario, if I imagine now that I've been sort of like hacking on, I started with Cursor and I switched to Windsurf because at that time I don't use it anymore. But when I did use Windsurf, I felt like it had better memory, and I
Mm,
learned later that that's, well, because it can go grab all these different files as context, hold it, and while you're having a conversation with it, it's sort of like parsing the system as a whole, not just one file. And then
mhm.
I stuck with Cursor for a while because of that. But then now I'm on Claude Code, but only because I think I've been tinkering with them long enough that I've sort of figured out, okay, I get there's a boundary space that you can't just drop everything you want on these things because
Mhm.
it gets sloppy.
Yeah.
But yeah, so leading into your work now, because you're doing like breaking, um, ground on this new sort of like architecture around memory. And I believe you just did an announcement that, um, let me look at my other screen here, which was 21 hours ago. A new coding agent that rivals Cloud Code, but with no compaction needed. This is sort of like a pivot into the future, but why not let's go there
Yeah.
because it sounds like it's something you're really excited about. Do you want to unpack that a bit?
Yeah, definitely. So, like you said, like not everyone wants to build their own coding agent, right? Not everyone needs that. Um, but um, it is a very good way to see how this memory system works, to like feel it firsthand. Like a lot of non-technical people will even use coding agents, right? Like I think it's very common now.
Yeah, I'm doing it every day, multiple times a day for all different use cases. I'm just trying different stuff, and it's like,
Yeah.
okay,
And I think even like what like the Claude Cowork or whatever is like built on top of Claude Code, right? So these things are very powerful. So the reason we shipped this is we had this internally and we've been using it for months. And the reason that it was initially built was to use this memory system, right? And so
it's awesome.
the cool thing, like now that we've shared it, is other people can very easily try the memory system. So we did see some community members making like what is it, Pi agent plugins for observational memory, open cloud plugins, and some other ones. So people could try it that way. But we thought, oh, why don't we make it really easy to try like the official one as well, like to see like our version, so you don't have to use Mastra to use Mastra code.
Okay,
Um,
that's good to know because
yeah,
I didn't know that.
it's basically it's just like Cloud Code. Basically, like you'd install it and then you'd run a command and then you get this kind of terminal interface where you can just
Yeah,
start chatting. Um, and it has this observational memory just built into it. So,
and then so not only is it beneficial for the human interaction with an assistant or agent,
mhm.
it also saves money. And is that because of the way that you're doing the compaction because of the memory architecture?
Yeah. So something that we found that's very interesting is with observational memory, you can have a much smaller context window size and it behaves like a longer one. So when you're using like Claude Code, you might fill up your context window to like 200 or I don't know, 180,000 tokens and then have compaction run. Now that's actually quite a lot of tokens.
Yeah,
So there's a lot of context rot in there. There's a lot of just irrelevant info mixed in with info that
yeah,
is relevant, right?
yeah. Can I think of it as like too much noise and
Oh,
then
yeah,
that
exactly.
just washes out the signal, right? It's like,
Exactly.
and you got a guitar behind you where there's something to be said about like a nice crisp distortion that adds
Yeah.
color to the vibe, and then there's like over like the top feedback and nobody can even hear it because
Yep.
oh my god, there's a screech or something.
Yeah.
And I loved how Jeffrey Huntley started talking, helping me understand what context rot is,
Mhm.
and this idea that like yeah, there's just too much signal, and you're just trying to get these new technologies to do too much, and you're actually doing them a disservice by
Totally.
giving them too much context. So
Yeah,
you get smarter about what you're giving them, and you can get cleaner interactions with them and better results out.
definitely. And so I guess that's sort of why we have seen now that like with observation memory, you can use a much smaller context window size. So the default setting is there's like 30,000 tokens for the raw
Yeah.
message history,
Okay.
which that's like way smaller than, Claude Code would use at like 180,000. And then the memory system takes like 40,000
Okay.
tokens. So that combined, right? 70,000 tokens. That's like half, right? And so the reason we think is that um, as the system is working, you have this observer agent. It's observing everything that happened,
Yeah, I love
and
that. Yeah.
it is contextually doing that, right? So it understands the full history. So let's say a tool call came in that had 10,000 tokens in the result.
This is that subconscious observer observing the
Exactly. Yeah, exactly.
yeah.
But it knows contextually that, okay, there was an interaction happening. There's like some work being done. This tool was called, and actually, there's only one line in this whole tool call that is relevant to the conversation. So maybe actually only like it's like 20 tokens out of this 10,000 token tool call is relevant, and that's actually happens very often, like much more often than people think. So we see about like 6 to 40, excuse me, 6 to 40 times compression between there, depending on the tool calls, which is
And
that's a lot, right?
yeah,
So
but this is an advantage, and usually people, or at least me, think about compression as you're losing something, but you're describing it as no, the compression is giving you something back.
yeah,
Not it's not a loss, it's a gain, which is kind of counterintuitive to think about.
yeah, and so actually we haven't talked about it yet, but the with observational memory, we did run long mem eval again, and we got the highest score ever recorded at 95% with GPT-5 Mini. Now, the benchmark model that you're supposed to use is GPT-4o, and we did that as well. So you do that to compare with everyone else who also published results. And not only did we get the highest score on that, but we got higher than GPT-4o when you just give it the answer. So that there's like a baseline. It's called the Oracle sessions, right?
Yeah,
So
okay,
you
okay.
only let's say you have like 50 conversations,
Yeah.
and then you're going to ask a question, and one of those conversations has the answer.
Yes.
So if you just give the answer session to GPT-4o and then ask it the question, it gets it right about 82% of the time. Now, if you run the same question with observational memory, it gets it right 84% of the time. So it's actually 2% more accurate than if you just give it the raw conversation. So
Cool.
so a lot of people are like, "Oh, isn't it going to lose details?" But it's like, yes, but those are the details that didn't matter, right? The ones that do
Yeah.
matter are actually represented in a way that's easier for the model to understand.
Wow, that's just incredible, man.
Yeah, it's
Very
pretty
cool.
cool. We were not
It
expecting
is.
that result, but like,
It is so
love,
cool. And
yeah,
yeah, yeah, that you're like you're trying to solve your own problems and you're starting to play with these alien technologies
yeah.
is what Jeffrey Huntley and I like to call them because they're just like we're all learning on the fly about what is the boundary space of these things, what can they do, and it's people like you that are doing these interesting experiments that then turn into better ways to work with them. So this is super exciting, and then I did see some people posting now that okay, I want to try some of this stuff that you're doing on their open clause. This was even before I was um, trying it myself. Where do you think things are going next, Tyler?
Like for this like memory
Just,
system or just in
yeah,
general?
well, just in general. I mean, I think memory systems help us reduce cost
Hmm.
and get better at not wasting a lot of energy. I mean, like
Yeah, definitely.
so it's super cool in that direction. I think maybe it becomes just a fundamental principle. Actually, let's say now that you have a smaller context window in this new tool that you built, does it inform the user if they try to put in too much context that it's like, hey, there is a limitation here. Don't put in as much context. Like, how does the
No, so
user?
it does, it naturally just handles long
Okay,
context. So those are the default settings, but it can spike above those thresholds. So you could still use, like, let's say you wanted to use, some people do like browser automation, and that uses tons and tons of tokens. So it might spike up in a single tool call like 60,000 tokens or even 100,000. So the system actually just accounts for that. Um, it will just, it'll see, oh, suddenly this spiked up really high, and then it'll observe what happened and then make it smaller
oh
basically right
wow,
away.
cool, cool.
Yeah.
I would love to just watch some of these workflows being used where you can really see that architecture doing the smart compression. It feels like noise gating. Is that the in music when we're like
Yeah.
when we're trying to like clip spikes? You know, there's certain methods you can use in audio engineering to sort of clean that up. It
I think
just
that's a pretty good metaphor actually of like,
yeah okay
like, cause yeah, it goes past the limit, and it's like, okay, that
yeah
part
yeah yeah yeah
needs to be
yeah
accounted for and brought
yeah.
down.
That's kind of what you're doing.
Yeah.
If I had a mental model of what's going on, yeah. So then, where do you think you're going next? It doesn't have to be related to observational memory, but where do you see these technologies taking you, your team, Mastra, customers? Where do you see the space going?
That's a really good question. So one thing that I found really interesting so far is now that I'm able to use this system in the coding agent, it's actually accelerating the work that I'm doing. So I'm like using it to work on itself, but also new things. So this like super long context understanding is actually, I think it's going to actually cause like sort of like an explosion of us being able to do more.
Yeah,
And I think generally that's going to be the case for all these technologies, like every advancement.
yeah,
Um,
yeah,
I'm hoping that specifically observational memory catches on and just becomes a thing that people do in the industry. It's sort of like what happened with compaction. As this could just be like a better version of that. If Claude Code started doing this, we would be happy. That would be amazing.
yeah, yeah,
So
yeah, yeah, yeah. Yeah, no, no, totally. And I also see, yeah, there's a couple camps that are like the rate of change is so fast and the acceleration so fast that it obviously makes people anxious. But I am on, and then there's the other camp where
mhm.
you are, and same with me is like I know it's scary, but I think it really unlocks your human potential to do more that you couldn't do before this technology
Yep.
because you were locked doing repetitive things that machines are just better at. But
Totally.
now, especially with the long running agents, and this is why I love the conversation with Jeffrey as well, dovetails nice into the conversation with you, is that I think very early we were like, what can this agent do? And it's very like, it's on a short leash because it goes off the rails. But
Hmm.
now the smarter engineers like you are coming into the play and they're like, hey, well, I can stretch my agent to get, 24 hours, or Jeffrey Huntley is like, I can get it to go 24 hours. Now it just means, well, that means it can do more work. And
Yeah.
wow, what an unlock that happens when longer horizon tasks can be achieved because you have an agent that's, I guess you still need good goal directed specificity into what the system needs to do.
Hmm.
But I think we'll just get better at that as well. And
Oh,
then,
totally.
I see a camp that's like, hey, everything was moving really fast, but now there's all this unlock happening and it'll allow you to do some of the things that humans really enjoy doing.
Yeah, like the more creative, like interesting
Yeah.
parts, right? Rather than kind
Yeah.
of repetitive,
Yeah.
finding all the little tiny details where things are broken. I mean, some people like that, but I think a lot of us don't. you
Yeah,
know?
or even like even if it was like I never could write code, right? But now I can talk to my systems,
Hmm.
whether that's chat or an open claw, and I'm like, I kind of need. I keep doing this, and I don't want to keep doing it. It's repetitive.
Yeah.
Like I don't mind doing it once, but then if like, oh my god, I've got to do this over and over and over and over and over. Before you had to hire an engineer and say like I need a way to get around this, and somebody would have to hard code that
Hmm.
problem to get solved. Now I mean we're talking to
Just describe
computers.
it, right? Like,
Yeah, and then I think we get rid of, not get rid of, well, we have machines that become symbiotic with us to say like, hey, that's a repetitive loop, just help me automate that, and then I'm going to go get unlocked and help go towards what gives me energy.
hmm
And right now that for me is I run events here. We just finished a voice hackathon. Um, we just finished a voice hackathon. It was so exciting, and there's just so much like growth from this where people are like, I want to go do this, I want to go do that. So I'm trying to find a way to go. How can I help more people go out and solve problems really
yeah.
through the network here. So, but then what's next for you, Tyler? Are you what's going on in the wheelhouse after this announcement you just made 21 hours ago, or is there anything else I can help you sort of like connect to, and if you could connect with anybody?
Yeah, I think like right now there's just been so much interest in these two things. Like we're going to be basically supporting them, helping people out,
Yeah,
adding things to them. We're also like we've seen a lot of interest in being able to use this memory system without using Mastra. So that's something we're working on right now. So there'll be probably an announcement about that, at some point in the near future. So you'll
cool.
be able to just anyone can use it without having to make a master project or write TypeScript.
Okay.
And yeah,
Okay.
so that's coming soon.
All right.
Nothing to check out yet, but
All right. All right. Coming
yeah,
soon. Coming soon. Love that stuff.
yeah,
Yeah, because I'm doing a open claw night tomorrow, and we have,
cool.
yeah, we're in Waterloo. Where are you, Tyler? Are you in Toronto or?
No, I'm on the West Coast. I'm on Vancouver Island,
Oh, you're in Vancouver. Okay. Is Sam in Toronto, or is he over on that side too, or in California?
California. Yeah, I
California.
think in SF.
Everybody's all over the world now, but you're in
Yeah,
Vancouver. Okay, cool.
yeah.
Yeah, we're doing open claw night tomorrow, and I think we got 130 people, but I like to propagate the new news to people. So this is going to be exciting. I'm going to be able to
Amazing.
share some of this stuff because I had no idea that this framework is sort of going to be like, hey, you can give it to an open claw. Um,
Nice.
or
And
yeah, yeah. Sorry, go ahead.
I was just gonna say, so yeah, if you do share with anyone, and for anyone listening, like if you use this stuff and you run into any issues, like please open like a GitHub issue. We also have like a Discord, so we're like always wanting to help people and make sure they're successful using this stuff. So just wanted to
Cool.
shout that out.
All right, and then I'll add that in the show notes after when the post recording is done. I will add that. And where else can they find you, Tyler? Do you want to be found on X, or how can people find you if they want to follow you?
I think on X is the way to go. Yeah. So my handle is TYLBAR. So first
Yeah,
three
and I'll
letters of my first and last name, Tyler Barnes.
cool. and I'll add that to the show notes as well. Anything else we didn't talk about that you feel like you want to share, Tyler?
Oh man, there probably are so many things, but I don't know. Nothing comes to mind immediately. But
Okay, okay,
this was like a lot of fun.
yeah, it
Yeah.
was. We covered a lot. Context is so cool. I think modeling the the human memory system that you believe helped you get to a engineering architecture is just such a
Hmm.
smart thing to do, right? Like nature knows how to design systems, and
Yeah.
why aren't we emulating them?
Exactly.
So I love what you did, man. And
Thank you.
if my Ren bot is trying to copy it, I don't know.
That's awesome.
I'm learning this stuff in real time, so I will be live hacking tomorrow, and I'll catch up with my OpenClaw to figure out because I haven't given it a job yet. Nothing major, anyways. I've
Mm,
got it. He's got his own email, and then I'm like, I built the memory architecture is one of the first things that I built,
mm,
because I'm chatting with it, and I wanted to start remembering what we're chatting about, and then it's uploading some of its architecture to GitHub so that I can actually look at its how it's architected, its own system. So I love it, man, and I think we're at the very seeds of people doing very creative things with it. And we talked about you being a pioneer, breaking ground on this. So thank you so much for your contributions to helping everybody understand how to play with these new technologies in a way that is meaningful, but also saves them money and time. So great work, Tyler. I appreciate what you've done.
yeah,
And
thank you.
yeah, thank you so much for coming on the show. It's such a pleasure to talk
Yeah,
and
thanks for
hang out,
having
man.
me.
All
It
right.
was a blast.
Okay, Tyler, take it easy, man.
Yeah, you too. See ya.
Cheers. Bye.